College Algebra, Topic 3.3. Number 2, we want to show that this is not a function, or demonstrate this is not a function. So what we're going to do is I'm going to choose numbers for y. Let's choose y equals 4, and then we'll choose the opposite as well. We're going to choose y equals negative 4. Now if y is 4, we have x and 4 squared equals 3,600. 4 squared is 16. Now I'm going to divide both sides by 16, and I'll get 225 for x. This means that we have a point of 225 for x and 4 for y. Now, using the negative 4, we have x times negative 4 squared equals 3,600. And negative 4 times negative 4 is also 16 equals 3,600. And then we divide both sides by 16. I have x equals 225, which is x is 225, y is negative 4. And this, and having 225 4, 225 negative 4, demonstrates that this is not a function. Okay, now for this one, k, the function k is going to be 1 over x. This is the difference quotient. So we have the function k with a plus h as an input. That means that we're going to have 1 over, instead of x, the a plus h. Then minus k of a will be 1 over a instead of 1 over x. And then everything's over h. Now, from here, I'm going to multiply the numerator and denominator by the least common denominator, which will be a times a plus h. Okay, so this gets multiplied, and this gets multiplied, and then that gets multiplied. So, numerator-wise, when I take a plus h divided by a plus h, I get a times 1 is a. A plus h divided by a times 1 leaves negative parentheses a plus h. Very important to have the parentheses there. If you don't, then this problem will not come out correctly. A plus h times h is h times a plus h. Next, we're going to distribute this negative, and we'll get negative a and a negative h for the numerator, all over h times a plus h. Now the a's will cancel, leaving negative h all over h times a plus h. The h's here simplify to 1's. So we end up having negative 1 all over a times a plus h. And this is our expression. Okay. Next, we want to do a composite of g composed with f. G composed with f means g is the outer function and f is the inner function. Now I'm going to look up the inner function f, and it is x squared plus 2x plus 1. So g of x squared plus 2x plus 1. And now I'll look up the function g. G is the x term minus 5. The x term minus 5. Well, now the term is x squared plus 2x plus 1. And then we'll say minus 5. So this equals x squared plus 2x plus 1. This is where the x would have been. And then minus 5. Okay. The parentheses here, if we distribute a 1, simply becomes x squared plus 2x plus 1, and then the minus 5. And from here I can collect the 1 and the negative 5 and get x squared plus 2x minus 4. And this is our final result. Now f composed with f. This means f is the outer function and f is also the inner function. F being the inner function means we're going to use all of this, which is x squared plus 2x plus 1. Okay, now we'll look at the outer function. The outer function is still x squared plus 2x plus 1, but everywhere we see an x and x, we're going to put this entire parentheses in there. So this will be parentheses x squared plus 2x plus 1 all squared plus 2 times the parentheses x squared plus 2x plus 1, and then the last plus 1 there. Alright, now this right here I'm going to expand into x squared plus 2x plus 1 times x squared plus 2x plus 1. This I want to distribute, so I'll get 2x squared plus 4x plus 2 plus 1. Now here we'll do some, how should I say, some foiling on steroids. I'll multiply x squared with all three of these. So x squared times this gives me x to the fourth, x squared times this gives me 2x cubed, and x squared times the 1 gives me x squared. Now I'm going to multiply everything by 2x. So this times 2x gives me 2x to the fourth. Sorry, 2x to the third, my fault. And 2x times 2x gives me 4x squared, and 2x times 1 gives me 2x. And now I'm going to multiply everything by 1. If I multiply everything by 1, I'll get an x squared plus 2x plus 1. So x squared plus 2x plus 1. And then I'm going to add all of this to this. So these two will be combined. So this second piece plus this first piece here. So we'll have x to the fourth. My x cubed is here and here, so it'll be plus 4x cubed. Oops, sorry. With that. My x squares are here, 1. 4 more, that's 5. Here, that's 6. And here's 7, 8. So plus 8x squared. Now my x's. I have 2 here, that's 4. And another 4 make 8. So plus 8x. And now for my constants, I have a 2, a 1, and a 1, so that's 4. And so this is my function f composed with f.